So we're going to be talking about reducing impact for your critical workloads. We all know that we've been in situations with workloads over the years, and hopefully you guys are going to all learn some great tips today and some best practices and patterns on how to minimize impact when you have impairments or events that happened on that. We're going to talk about a couple ways that we can accomplish this. I'm going to introduce you to three people today. First, we'll talk about Alice, who's got a coffee shop, and we're going to tell you about how her coffee shop started from a very little small shop all the way until a very larger concern, and how she's worked on mitigating and really reducing impact through some difficult times. We're doing a little bit of an interesting experiment when you have the two of us presenting today. At AWS, when we think about and talk to customers about the most impactful or critical workloads, we always bat around ideas on how we're going to make those workloads the most resilient. And so a lot of the concepts that we cover today are really that conversation we as engineers have in thinking about how to do that. So we're going to share with you some principles for how to do that and what the best ways to accomplish it.
All right. Welcome, y'all. My name is Bruno Emmer. I'm a principal technologist at AWS. I've been working with the company for over 7 years now, and I'm joined by my very good friend, Byron.
Arneo, and I've been here for 3.5 years as a principal technologist as well at AWS.
All right, cool. So that being said, we would really like to start this conversation by bringing you up to understanding the business case, right? Like, we understand that resilience always needs to be in place, and it's very great when it's able to map the business need. So today we're going to talk about Alice, as Byron just explained. So Alice used to work in a company. She got some vacations. She traveled to Brazil, and she tried some really good coffee right there. When she came back to the US, she decided to quit her job and to open a coffee shop. At first, it was going to be a very small coffee shop. She just wanted to be like selling coffee to her friends, like to her neighbors right there. And really, when it comes about automation, she wasn't using any of that. She really started using the old method of pen and paper. So every time that she was selling an item, she was actually taking a note on her notebook. And every time that she was actually buying coffee to be able to sell in her store, she was actually also taking notes of that. As her business started growing, she actually found out that it was hard for her to be effective and taking notes at the same time, like manually taking notes. So she actually learned that she needed to have an IT system to take care of her orders, right? And this is where her journey started. And just bear with me, just a spoiler alert. I know you're talking right now about a very small coffee shop, but as we go through this conversation, it will become like way bigger than what it is right now, right? So just want everybody to be aware of that. But before talking about Alice and her coffee shop, I wanted us to start with a definition, right? And I wanted to start with a definition of resilience. So resilience is the ability of a workload to recover when something fails, right? So we are talking about the ability that a workload will have to get more resources, the ability that workload will have to avoid those failures, to kind of like keep operating even when something is broken, right? And even the ability that a workload will have to get back to its normal state when something breaks, right? So just wanted to make sure that we are all on the same page about what resilience really means. And this is like pretty much all what this talk here today is about. And getting back to Alice's coffee shop, right? It really started small. You remember I told you that it was like a small coffee shop. She was selling coffee on her garage. And really, she just started with a single instance of an order management application. So she built that instance. It was like very small. She just deployed that. She was actually using a database to host the orders, like all the information that she was having. And every hour, she would be taking a snapshot. She would be taking a backup of that database, because it was very important for her to be able to understand what was going on, even if there was like a problem. And when problems actually were happening, she would get back to the old pen and paper method, right? So she would be restoring the backups, but while she was actually restoring the backup, she would just be like taking notes using like pen and paper. So really, at this point, the area of impact that she was having, like when something was wrong with the application, if the application was having a bad day, if there was a problem, would really be one coffee shop. So when the application went down, her entire business would be down from a systems perspective. So the first area of impact would be really the coffee shop right there.
You know, and so that coffee shop really started to grow, as you'd expect, and sort of spoiler alert for the story. And as that started to grow, they opened up another coffee shop and needed to really scale out the IT infrastructure. We've all been in that. Think of your workloads that you have, and when that starts to scale, what things you need to be thinking about. And as she started to build new features into that, the deployment process, and as she was going through that, it could potentially have to take the entire server down or take the entire workload down. So with that being said, I wanted to sort of like just say, you know, and as she started to build, and we wanted to really think about how we would reduce the impact of Alice's impact on the system's resilience.
Well, and I guess that in order for us to talk about like how to reduce the impact, we could again just take another step back and start talking about resilient foundations, right? I think that it would be a great thing.
So there's two key things that you really want to consider here, right? Which is the desired resilience properties, number one, and the categories of failure, right? So from a desired resilience properties standpoint, you basically have 5 characteristics that you want to kind of consider. And so as we think about that, there's fault tolerance, right, which everybody knows here is kind of the key for being here. And that's thinking about things, whether it be HA or things like auto-scaling groups or things you might do in storage, like we remember back in doing with RAID. There's other things like sufficient capacity, right? We don't want to really build that application. In Alice's case, should she turn around and have that new cafe, latte, mocha, matcha thing that she released on that day, do we really want to have the situation in which those things fail over on that day because we don't have enough capacity for it? And then timely output. Are the cash registers working in a way at her store in which that the orders are being processed and people are happy and that the coffee ends up at the other end of the counter at the right time? And then really this idea of correct output, right? Making sure that you got the right thing from the mobile orders on through the system that are actually ending up in the right place, right? And so lastly, fault isolation. And fault isolation, if I could emphasize nothing more to everybody and thinking about this, Bruno, when we talk about this, is really having those right fault isolation boundaries so that when we have impairments, and they're going to happen, and you're going to have failures, how we minimize that impact to only the smallest group of people.
And again, I guess that when we start the properties, it becomes very easy for us to start understanding how an application can actually break, right? So pretty much every time, like as Byron said, that an application is actually violating one of those properties, we are very likely going to face a failure. And a way of thinking about it, again, like keep evolving in this conversation, is actually grouping those failures in different categories. So first of them being single points of failure, right? So every time that an application lacks redundancy, every time that's no high availability implemented, we'll be talking about like having a single point of failure that has the potential to take your application down. As Byron said, another thing that we should be concerned is that additional load, right? And again, additional load might be something that will be happening to your application in specific days. So because Alice was in the business of selling coffee, she wanted to have like those big promotions every time, every year on the Black Friday. So she needed to make sure that her business was actually scaling enough so she would be able to take care of that additional load. Another thing though was that every day at 6 p.m. when people were actually leaving their jobs, they were going to the coffee shop and they are buying like more coffee. So she learned that this was like pretty much an example of when she needed to have that additional capacity to take care of those sales, right? And again, when she didn't have it, it would become like a problem of excessive load. So really the idea of excessive load is thinking about the amount you are able to process plus 1, because this is when your system is going to break. Another thing is excessive latency. Byron just talked about like the time that it took for an order to be processed. From the business standpoint, when we're talking about latency, everything might be fine. My server is actually sending a correct response, but if it's taking too much time to get to my user, the user will have the impression that the system is actually impaired, that the system is not working, right? And this is really a manifestation of excessive latency. Misconfiguration and bugs is another thing. So if Alice just pushed a feature that was actually wrong, that was actually not doing the right stuff, if somebody went there and wanted to buy cappuccino, but instead of that, the person was actually getting a mocha, which is a different thing, this could as well be thought as a failure on the code. So a misconfiguration and bugs would be like another thing that would cause the system to fail. And pretty much every time that the failures actually were happening on like those different ways, and they were crossing fault isolation boundaries, meaning that the failures were not contained, we would have the example of shared fate. So we will talk more about shared fate later today, but a way of thinking about it is if Alice had a dependency on an external application, that external application failed, and it had the potential to take her entire business down, and this was not a desired property for her, this was not something that she thought about before, it would be a bad thing, right? So this is really the idea of shared fate. And again, just mapping all those different properties to how an application could fail. And it's important that we understand that, because when we have this point of view, we'll be able to start anticipating and avoiding this kind of problems, this kind of impacts to our business.
So I saw all of you taking copious notes and pictures on this. Let's think about how do we actually apply these concepts to a workload?
So in order to that, I would say, let's go back to the coffee shop, right? Because this is the example we are using right here. So do you all remember that everything Alice had was being served by a single application? She had the order management application that was using one database, and backups were being taken like every hour, right? This approach like worked for Alice for quite a while, but it was actually bringing a few challenges. Alice noticed a few things that would go probably wrong with that. The first challenge with this was that the order management application itself could be considered as a single point of failure for her business. Every time that this application was down, everything would be down. She wasn't really thinking about like how to implement high availability. She wasn't really thinking about how to avoid this kind of issue. And actually one thing that was happening was that every time that she was changing the application, every time that she was like trying to put a new feature in, or if like something was blue and she was trying to make it green, she had the potential to take the entire system down, because everything was tied. She just had one instance of the application, and the application was serving everything. So from this perspective, it's safe to say that that application itself was a single point of failure. And again, when we start thinking about the area of impact that it could have, and just taking a step further, when we were like just discussing the application, not only all the coffee shops would be impaired if this application went down, but actually all the features that the application was serving would be impaired for all the coffee shops. So we're talking about like a huge area of impact in this case. So I know that you all are probably thinking this very same question right now, but I'm going to ask it anyway to Byron, which is like, how could we help Alice, Byron, to reduce the area of impact for her coffee shop?
Yeah, so we could take a rather simple design, right? The single application. And we've got this order management system. Let's think of it like a cash register or the front door to a shop. And we've got an RDS database, typically behind it. Maybe we're going through some backups on that. And what we really want to do is to be able to think about that where we could move this more to a microservices kind of approach. So remember, we started with this cash register and this simple order management system. But what happens if we decomposed some of these key features and the critical features, the user journeys, through our system so that we can create actually 4 systems out of that for our order management system, right? So that's an inventory management system, maybe it's the customer loyalty program, maybe it's the coffee pricing engine. And now when we look at that, that's actually creating for each microservice one feature in the system. So when we think about that blast radius or that impact where we have that, that's actually going to be removing or decomposing or reducing that to just one particular application for that.
Well, and I guess at this point, it's somewhat easy for us to see some of the benefits of that, right? So by isolating the environment through like microservices, as Byron was saying, like in this case for Alice, the first benefit that she would have access to is that each feature would be failing independently. Meaning that if there was a problem with the customer loyalty application, for example, the problem would be contained to the customer loyalty application, and the orders on stores would be able to keep going through. So it's really like isolating the impact of failures to specific features. This would be the first one. The second one that I like to point out here is that she would be able to have the ability to pick the right technological stack. And we might be thinking like, why does it mean? And the real thing is that in order for us to build more resilient applications, simplicity is key. We don't want to have like systems that are overly complexes, right? Because like as simple it is, it's better, it's easier for us to manage, it's simple for us to maintain, right? So when we're thinking about it, if she had like one of the services that needed to have some persistence layer, she would be able to use the right tool for the job. If she had like another system that was just like storing ephemeral data, she would be able to use the right tool for the job as well. So it would really help her to build a more resilient system overall because she was using like, again, the right tool for the job. The third benefit that she would get from that approach is that it would be way easier for her to scale the application. If you remember like before, she just have like one single application and all the features were being served by that. If due to like some promotion or something that she was doing, actually the number of customers trying to like join the loyalty program was actually increasing, she would have to scale pretty much everything because this would be the metrics that she would be looking at. With this approach, she would be able to understand how each service works independently. So remember we were talking about sufficient capacity, right? And we were talking about how to provision it to meet the customer demand. She would be able to get the right data, the right information. She would be able to understand how to scale each service independently without having to mess around with like all the environment at all. So this was like very easier as well. And finally, she would have the ability to perform isolated deployments, meaning that the other problem that she had before, remember like when she was turning like stuff from green to blue, she could break everything on the system. It would be very, very reduced in this scale because she could have like the customer loyalty program, for example, being updated, moving to a newer version, while the order management system would still be untouched, right? Meaning that she wouldn't need to play with that at all.
So just as we talk about this, I'm sure many of you have heard of microservices before. But I want to say it's not the panacea to all solutions, not the solution that we would use for everything. There's definitely complexity that's implied with it, right? So if we've got microservices in our particular example, in which we said, hey, we've got 4 of them, there's a lot of complexity involved with deployments of that. I'm going to have to instrument for observability across all of that. So you start getting into multiplying that out by each one of those services or those features in Alice's coffee shop so that it starts getting more complex in the way that we're having to deploy it. So it's a balance that you're going to have to strike, but as a isolation mechanism and reducing area of impact, it's really a good mechanism and a way to achieve that.
And again, Byron was just talking about the area of impact, right? But we would be really able to see that the area of impact for Alice by adopting this approach with microservices was really reduced. Instead of having every single feature breaking for every single store, which was where we were before, she would really be able to minimize that to one feature being down if there is a problem with one of like any of those applications to all of her coffee shops. So like we went from like everything like I'm not able to sell to like, well, there is one feature that won't be working on my environment. So we are really like thinking about reducing even more the area of impact, and this is how this approach could be used in this case.
You know, so with this being said, does this system design have a shared fate?
Well, and again, we were just talking about shared fate when we were describing the categories of failure, right? And one of the things that I told you is basically the definition of shared fate is when a failure crosses an isolation boundary. Right? We can think about it on 2 ways, right? If I never thought about the impacts that would cause to my application, and it happens, then it would definitely be a bad thing. We would definitely be like a bad day because there was a feature, like a failure somewhere. Let's say that a dependency failed, something that I was relying on failed, and my entire system went down. This is not what I want. But I just wanted to be very clear that sometimes this might be the behavior that you will be pursuing for your applications. Sometimes you rely on dependency, the dependency will go down, and you are actually taking the decision of saying, if that dependency is impaired, then I don't want my application to be working as well. So I just wanted to be very clear to start with that, because shared fate might be actually a good thing if you thought about it. If you never thought about it, it's going to be a huge problem, because again, you will have a failure happening somewhere, and this failure is cascading and taking your entire system down, and this is what you will want to avoid. In Alice's case, like we just talked about how she moved from like monolithic application to microservices, and we've been seeing this architecture multiple times here. But one thing that she never realized was that even though she was using multiple services like microservices, everything was actually, in her case, deployed to a single availability zone. Right? So she just have like a single AZ implementation. And the issue with that would be if that there was a failure, if there was an impairment affecting her ability to process those transactions, those coffee orders on that specific availability zone, her environment would go down, like the entire application would go down, right? So having a single AZ design, in this case, wasn't really something that she thought about. It would be something for her to avoid. Because again, if there was an issue with the availability zone that impact the ability for her to keep processing, it would take the entire application down. So it was not something that she actually wanted to have it. And again, I guess that the next question that shows up is, how could we help Alice to reduce the shared fate on this environment?
Yeah, and so these are some of the key foundations, and I think a lot of you, hopefully at this point, are thinking about these, but thinking about the fact that we have 32 regions globally, that we've got availability zones, which are kind of the sweet spot, and we're going to focus a lot on that as we talk about this today, and then really the data centers that comprise those availability zones. You know, one of the things I often hear from customers, you know, Bruno, this comes up over and over again, where people are thinking about taking their on-prem environments and they think about those data centers, and they, in their heads, translate that to availability zones. In fact, availability zones in AWS can be comprised of many data centers. And each of those availability zones have their own connectivity, their own infrastructure, their own power supplies, and all of these components. And when we think about fault isolation boundaries, right, that's the part that I really underscored here. And I said, hey, this is the key mechanism that customers should really use in order to ensure that they're minimizing the impact that they have for their applications. This is one of the key ways to really be able to do it, is through this.
So again, one way for Alice like to avoid shared fate in this scenario bottom was actually by basically moving from a single availability zones to multiple availability zones, right? And this is really like leveraging the fault isolation boundaries that Byron just explained to us, and like avoiding this idea of shared fate between her workload and the infrastructure provided by AWS. If there was like by any means an impairment with one of those AZs and her workload wasn't able to be like processing orders, by like deploying across multiple availability zones, it could not affect her at all, right? Because she would still be having the ability to process those orders. So she would be still able to be selling like coffee on her stores like as usual.
So Alice's business continued to grow. You know, she's now got hundreds of stores across the country. And recently, as you might expect in our story, she had an impairment. That impairment cost her $537,000.22. This is a pretty big thing. Her venture capitalists, the people that were talking about her store and expanding this around the globe, got kind of concerned. And so this has become one of the things that's made her business too big to fail, right? And Alice really needed to go to this next level of thinking about how to reduce the impact even further. She had this vision, right? Like I told you earlier, which is that Alice said, hey, look, I'm looking to make this national global store. And you can see this vision that she had in her head of coffee everywhere. But unfortunately, with that type of impact and that news story that's out there, with that impact across all of her stores, it started to impact and shake the confidence that people had in the application. Does that sound familiar? And so how could we do to really reduce the impact so it doesn't affect all of the coffee shops at the same time? Is there another mechanism that we could use to get even further?
Sure, and again, I think we should just take another step back to understand how things are working, to then be able to understand how to improve that. So if we remember, all the stores were actually talking to the microservices that Alice was deploying across multiple availability zones, right? And again, to that point, if there was impairment, if there was like anything wrong with one of those services, all of her stores would basically feel that impact, right? So if we were like there buying coffee or cappuccino or whatever, we wouldn't be able to do so. So one thing that Alice could do would really be changing the way she was actually connecting the stores to the application. And by changing the way she was doing it, it would be really by thinking about having multiple copies of the application. She could have like the same applications, the same microservices, understanding everything that was needed, and deploying multiple copies of that. And then she would be able to just pick some of those stores and map to those instances of the application to those copies. By the way, Byron, those copies that we are talking about, we could call them cells, right? So this is really the notion of like moving to something that would be much more distributed in this case, right? So she could move towards like this cell-based architecture and start cellularizing the data there, right? So this approach would bring her like some benefits as well. For example, if one of the cells had a bad day, let's say that she was deploying a new feature, or like something went wrong with the application, right? You name any of the categories of failures we talked about, let's pretend that it was actually happening to one of those cells. The only ones that would notice this impact would be the stores talking to that specific cells, right? All the other stores would be able to keep operating, working as usual. So if she was like, for example, mapping those cells to states in the United States, and like eventually the cell that was having a bad day was the cell that was supporting Nevada, and we were here in Vegas trying to buy coffee, we wouldn't be able to. But users from California, from Colorado, from like Florida, for like Bogota, Colombia, they would still be able to keep like buying coffee. It wouldn't really impact them at all. So we are really talking about, again, with this approach, reducing the area of impact even more. We are going to one feature, like impacting all the stores if there was a problem, to one feature impacting just a few of the coffee shops in case of a bad day.
Yeah, and so when we think about cell-based architectures, right, and it's a big concept that we sort of introduced here, it's taking the entire application, maybe that microservice that we talked about earlier, and taking that entire stack and putting it in a single cell. And it's great isolation. Again, some complexity, and we'll talk about that comes with this, right? One of the ones that is the biggest impediment, or one of the blockers, is really thinking about partitioning your data. So we used that example before, and we said, hey, there are stores that are in different states, or maybe we broke it up into 3 different cells that were representing the East Coast, Central, and West Coast. And so when we thought about that, we would have to actually go through and take our database and our data and partition that in such a way as that each one of those regions map to a different cell. You could do this across what dimension makes sense. I've seen customers, and I know people that do this, and maybe it's financial services, and they're taking that for their market data systems, and they're basically breaking it up by equity symbols and putting those in different cells. I've seen many ways that people accomplish this, but I want to just say that this particular piece, there's some complexity involved with that, right? And one of the key things here is really to have that complete isolation between cells to really be able to limit and maintain your failure. And by the way, that's not partial isolation, that's full isolation. So when we talked about that single point of failure, having a database at the bottom of that stack that's shared amongst your cells would not be cell-based architecture, right? Because you'd be sharing fate with something else, right? And then the other thing that's really kind of a key advantage is really being able to linearly scale out so that you can add cells as you need to add capacity. And there's a lot of predictability in the fact that you have a cell and that you can sit there and say, I understand the characteristics of that, right? And so when you think about that, remember, sharding is the key for the implementation of cells.
Yeah, and again, like when we talk about cells, again, as Byron just explained to us, we would be really reducing the area of impact for failures. Because again, you all remember what happened to Alice's business when she had a bad day, right? $537.22, plus featuring front page of the major newspapers across the country because the coffee shop was down. So when you don't have those isolation boundaries implemented in your application, and your application is having a bad day, everybody would notice that, everybody would feel that, and this again would have the potential for becoming front page news. With the implementation of cells though, what we would see is that if there was a problem with the application, even though those users would be impacted because they, like some of the users that are mapping to this specific cell wouldn't be able to buy like their coffee, especially if it was cold. So it's not, I'm not saying that everybody would be happy, but like the impact would be heavily reduced. So it wouldn't be like all the users are not able to buy coffee. It's not like everything is down. It's really like some users are not able to buy coffee from Alice. And this is how we move from like front pages to back pages in the newspapers, like basically. But one of the things that Byron was explaining kind of like made me think, and I feel we could dive deeper on that, Byron, which is when you are explaining cells, one of the things that you just mentioned to us is that every single cell is like a full stack. Mm-hmm. There's no shared fate, there's no shared database, right? So it makes me think that every single individual store needs to know where its data is, right? It needs to have like this intelligence right there. So when it comes about that, would you mind explaining like if the data is partitioned, how each store will know which cell it needs to map or it needs to connect to?
Yeah, it's a great question. And the way that you accomplish this, and a lot of you might think, you need to add this thin routing layer, right? And you might think to yourself, well, I've just introduced a single point of failure. And I'm going to tell you that you did, but one of the things from a best practice that you can do is to really keep that ultra simple. What does that mean? Right, so I could think about something where I might have 5, 10, 15 lines of code. I don't want to be doing something where I'm going and polling from a database to be able to service the request and figure out where somebody's going. Maybe I want to push that mapping into my routing layer on a regular basis and make it very statically stable. Right, I want to really ensure that this is ultra resilient. And again, that complexity and adding a lot to that routing layer is definitely going to be the type of thing that adds a lot of complexity, right? So, and it needs to be ephemeral. And so when we think about that, there are some key system properties that you want to kind of consider, right? And so workload isolation, we talked about that a little bit, making sure that that cell and it's that full stack that's only in that cell is really a key for that. And then failure containment is another property, right? Because again, why we're here and we talk about minimizing blast radius, and by the way, here's a little bit of a secret. You might start, the bells might start going off in your head. This is what Amazon does. When I talk to customers all the time, the biggest question I get is, how is it that you build these hyperscale services in such a way where you have hundreds of thousands or millions of API calls that are happening inside seconds or minutes, right? And so really having that failure containment is one of the key things that we do for that. So when we have a service that's impacted, as an example, in a single cell, maybe that's only representing 1/10 or 1/20th of the entire workload that you have. And you can see as the example that we give here, right? In this particular case, the other cells are not impacted. And so you may remember, if you've ever seen some of these things before, you say, we may have some things that are impacted, but some users may have some gradual recovery on that. That's because we've cellularized it so that we don't have the entire platform, the entire service being impacted at once. And so this also gives us another ability to really scale up and to scale out as opposed to just scaling up on this. And one of the key ways that we really do that is because cells have a maximum size. Now think about this, right? We went ahead and we build our system. And in Alice's case, she knows that she wants to be able to do 1,000 cups of coffee per hour on a register or at a store. So when I've tested that, I make sure and I say that all cells have a maximum size. I don't want to get into a situation in which that I find out, because my infrastructure has scaled to a point that I have not been before, and how that's going to impact my application. And so by basically having it setting up at this maximum size, the testability is now something I can do. So imagine, if you will, trying to emulate. We've all had this conversation. I come from a lot of years of performance engineering where you start to think, I've got 1 million or 100,000 things, transactions I got to be able to produce. But if I do that from a testability standpoint and I carve that up, and I'll just go and I'll say I've carved it up into 10 cells, I can test 1/10 of that, and I know the performance characteristics that I'm going to have from that particular cell, right? So the last thing I would sort of leave you from a system properties perspective on that is really the idea of manageability. Now, you probably are thinking to yourself, we've built these cells, and we've mapped these stores into it. What happens if one of the cells has a store that's gone crazy? It's in New York or Las Vegas, and reInvent came into town. And all of a sudden, everybody's going through and buying tons of coffee because they need to stay up during one of the talks or whatever, right? And so having the ability to evacuate cells and move larger stores into a different cell, you have to build that. There's no special software today, right? That sort of allows you to sort of like a cell management platform doesn't exist. So this is a kind of make your own kind of thing when you do this. So remember, and this is one key point that again comes up over and over again, right, when we're talking to customers about this, is that everything that you do from a resilience standpoint to any of your monolith or other application, you need to apply the same thing to cells. It doesn't change just because we're going to a cell how we approach HA and DR. It's like having that, and that's back to that complexity part of it again. This is not a trivial type of thing. This is for your most critical workloads where you really need to be able to have that critical degree of isolation for your most important workloads. So cell-based architecture was great, but the order processing system used by Alice's employees were very critical for order processing, right? And so when a cell was impaired, the whole store would be impacted in the example that we've given so far. And Alice wanted to go, and she wanted to reduce the impact even more than the microservices and things that we've talked about today. She wanted to go to the next level with that, more than cells. So could Alice make the order processing system even more resilient?
Well, and I guess that this is where we will start talking about a different architectural pattern that would help Alice to implement even more resiliency for this specific service, for the order management feature that she was talking about. And again, in order for us to understand like this additional architectural pattern, I want to invite you all to take a step back again with me to see like how things are progressing, right? So let's pretend that each of those images right there were actually users interacting with the cash registers, right? So if you wanted to be like fun, we can just call them cat registers or dog registers, right? But these were like really the users interacting with the order processing feature that she needed to build more resiliently. One thing that could be happening is that if one of those users, if one of those cash registers was actually sending a bad request to the server. And by a bad request, I'm really talking about like a poison pill. We can talk about like a flood of requests, like sending more data than what expected. This could have the potential to get to one of the services and take the entire server down. right? So this would be happening. But the thing was, because Alice, since day one, was actually thinking a lot about resiliency, she actually implemented mechanisms for that, right? So Alice was very smart, and she said, if there's a problem like this happening in my environment, or if a client tries to talk to my server and it's not available, guess what? I'm going to retry. And then this retry, because it was a bad request, would have the potential to take another server down, and another server down, and another server down, and so on and so forth, until all the environment, like the entire system, be impacted and like stop working properly. So here, we're really talking about an area of impact that would affect all customers. This is how it was working before. Moving forward, we talked about sharding, right? So when we introduced the concept of cell-based architectures, it kind of like changed, right? Because these applications, or the users interacting with the applications, the cache registers, were not all sending like the requests to the entire fleet. We were sharding the data. So in this very same case, if the user cat was trying to like get an order going through, but this was a bad request, it would actually get to the shard. It would certainly take a server down, like assuming we are talking about the same problem with poison pills, the server would be impacted, the user would retry, and it would actually stop right there, taking the entire shard or the entire cell down. But we can see that this was actually better than what we had before, right? Because all the other users would still be able to get their orders through. So this was pretty much what Alice would get by moving from like a monolithic to like cellular architecture, right? This is what we just discussed. So the area of impact in this case would really be the customer divided by the number of shards, which is like smaller than every single customer. So again, we are effectively reducing the area of impact right here. But there's another pattern that Alice could be using, right? And for us to like understand how this here works, we could really like shuffle it up a little bit, right? So there's a pattern called shuffle sharding. The idea with shuffle sharding is actually being able to use math to change the way we are actually allocating users to be interacting with servers. So if we were using shuffle sharding right here, instead of like just building the shards and assigning fixed users to those shards and have those users like sharing the very same infrastructure, we would be doing it slightly differently, right? So we would have the users, like each of the users would still be using 2 different servers, but they would not be like sharing the very same infrastructure, right? So this is basically what we would be getting right here. And if this implementation was in place, and even with this implementation in place, the cat was actually trying to place an order. And this was actually going to be like a bad request, such as the one that we just saw. It wouldn't really change from the client's perspective, right? The cat would go there and would take like one server down and then the other server down. The same 2 servers we saw going down when we were talking about sharding. But the difference right here is that because the user cat, in this case, wasn't sharing the same infrastructure with all the other users would be able to still be getting the orders going through. It would really reduce a lot the overall impact that those other users like would be perceiving. Because again, they were not sharing the entire shard, right? So it was really shuffled, right? And this is what we would get when talking about shuffle sharding, right? So we would be reducing the area of impact, in this case, in this example here, to a single user. Again, when we're talking about more users, more infrastructure, these numbers could be different. But basically what we would have would be an area of impact that is equal to the number of customers divided by the number of combinations possible to be achieved. So again, reducing even more the area of impact.
So let's review, right? We talked about 4 big concepts here in terms of what you could do to reduce impact that you have when you eventually will have impairments in your application, right? In the beginning, we talked about how we could take and decompose application or a feature into microservices so that we would not have an entire function that's impacted at once, right? Remember, when we think about that, the cash registers and the part where you actually take the payment on that might be a really critical feature. That's way more important than recommending whether or not that you should get a cookie on the way out the door, right? So that's really a key feature and a function of what she's doing.
Another thing that Alice learned was that by leveraging fault isolation boundaries, microservices being one of them, but also like understanding the AWS fault isolation boundaries, such as AWS regions and availability zones, and eventually even moving towards cell-based architectures, Alice would be able to avoid shared fate, right? Again, it's really isolating the problem and not having some of those issues, some of those failures, crossing the boundaries defined by her. So she would be able to leverage those and again, get over like the shared fate scenarios.
And as we just mentioned, Bruno talked about again, these cell-based architectures allowed her to have even more isolation. And again, I just want to say for the faint of heart, and I'm going to be here afterwards with Bruno and we'll be talking about how you do this. It's really going to be some additional complexity with that, but it'll allow you to have even more isolation by having these cell-based architectures.
And finally, one of the workloads used by Alice was very, very critical to her business. If this workload was down, her business would actually suffer from that. So for this specific workload, she needed extreme resiliency. She needed it to be very, very resiliency and to be able to outstand failures without impacting everybody else. Because she needed even more isolation to that, she actually decided to implement shuffle sharding. And again, shuffle sharding was complex. It's not something that like would be very easy to be implemented. This actually, out of curiosity for you, is something that we use at AWS as well. So Route 53, for example, makes use of shuffle sharding to increase its overall resilience. But again, it was very critical to her, and she decided to take on all the trade-offs and to implement that. And when she did it, she was able to increase even more the overall resilience of her system.
Yep, and so because it's reInvent, our story is going to have a happy ending. And so Alice's coffee shop, doing all of this isolation, got to the point in which that she became a national concern. In fact, I invite all of you after this to go have some Alice's coffee if you can find it. I'll go along with you. And you can see from this map here, we're now across the entire country. So using these isolation mechanisms, we've really gotten to a point where we reduced dramatically the area of impact.
And again, just wanted to share very quickly with you additionally, like in addition to Alice's store that we just talked about, AWS has released the AWS Resilience Lifecycle Framework. So the Lifecycle Framework is a framework that shares like strategies, services, and mechanisms that customers like you all could leverage to increase your overall like resilience posture. One thing that we learned when we were working with multiple customers globally was that resilience is not a thing that will just come, you just like do at one time and it's done, right? Resilience needs to be like executed constantly. And if we see what Alice was going through, she was like always trying to improve. She was like always finding like new problems and then like evolving her architecture to like mitigate those issues or the effect of those issues. And this is actually why the life cycle was actually created on the same lenses as a software development life cycle, right? The idea was that really users, customers would be able to leverage this across like the journey while building software. The life cycle has basically 5 different phases. It starts with setting objectives, designing and implementing, evaluating, test, operating, and respond and learn. And each of these phases, as I shared before, we will bring you insights, information, services, and mechanisms that you all be able to use in each of those areas right here.
Yeah, and so just as an architect, technologist, as many of you are here, I would say you may use different tools for this. There are a few ones that we provide that will help you along this journey should you choose to use them. The first one I'll just highlight for you, if you don't know, is something called AWS Resilience Hub. This is a great tool. I've talked to many customers and I see them using this in almost a governance kind of role, and it really helps you to understand your RPOs and RTOs and whether you'll meet them. So as an example, one of the things I love about around Resilience Hub is the fact that when you set your RPOs and RTOs, because it knows where your data is stored and the recovery for that, it can actually tell you whether you'll actually achieve that based upon the restore times for data. So that's really one of the great things about that. And the other thing I really love, and again, Bruno and I spend so much time talking to customers around this one thing, and the big question is, how do I improve my resilience, right? And I say, practice, 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 practice. Get to the point where recovery and what you're doing is second nature, that you're comfortable with this, that this is not something that you're doing for the first time. More times than I can tell you, I've sat on calls with customers during the course of events, and I hear everybody going, are we ready to do this? Should we fail over? This should be second nature. It should be the type of thing that you're doing as part of second nature. And so lastly, elastic disaster recovery is something that you can really use, and this helps you between backing up and integrating that with your on-premises systems as well to be able to enhance your ability to recover as well.
Yeah, some other services that we have that will help customers with that. One of them is going to be AWS backups. If you remember, Alice was taking backups from her database like every hour. When we start thinking about like how it can be improved, like how customers are able to take like backups from like all the data sources like running with AWS services, we have like this AWS backup service that actually helps customers to protect the data and to be running like the management of these backups very easily in a cost-effective way. Another service that we have is the Amazon Route 53 application recovery controller. So the Route 53 ARC, as we call it, is a service that helps customers to, with the management and the automation of the recovery so that they can avoid sending traffic to availability zones or regions when there are impairments. And this will happen in a very easy way, in a managed fashion. And finally, we do have the AWS Solutions Library, where customers will be able to find purpose-built AWS solutions, partner solutions, and we will also have the AWS Solutions Library that contains very rich information, such as the resilience lifecycle that we just talked about, that customers can leverage to improve their overall resilience posture. That was pretty much it, folks. I would like to appreciate you all coming here. Thank you all for being in the session. Thank you for being at reInvent. As Byron said, on your way out, if you ever find Alice Coffee Shop, make sure you stop by. We know that she is like relying on a very resilient architecture right now. And please, do not forget to complete the session survey and the mobile app. Thank you so much for being here.
Yeah, and thanks.